Hi, I'm Victoria, and I'm going to talk to you about significant figures. There are some general rules for determining the number of significant figures. Like, non-zero digits are always significant, and all zeros between non-zero digits are significant. Like in the example 4,305, all four of those digits are significant. Also, the number of significant figures is determined with the most left non-zero digit. The zeros inside the heart are not significant, so this number only has four significant figures, which are 7, 1, 2, and 9. Zeros that come after a non-zero digit but do not have a decimal are not significant. The underlined zeros are not significant, so the only one that would be is 1. Zeros that come after a decimal but are not followed by a non-zero digit are significant. 8.00 has 3 significant figures. Zeros that come after a decimal but are followed by a non-zero number are not significant. This only applies when there is no whole number. 0.09 only has 1 significant figure, and 5.008 has 4. Zeros that follow a non-zero after a decimal are significant. 0.77000 has 5 significant figures. When measurements are added or subtracted, the answer can contain no more decimal places than the least precise measurement. For example, the answer is 143 and not 143.4 because 100 has no places after the decimal and 43.4 has 1. So the answer should have no places after the decimal. When multiplying and dividing, the answer cannot have more significant figures than the least amount of significant figures in the equation. In 3 times 2 equals 6, the answer is 6 and not 6.0 because the least number of significant figures in the equation is 1, so the answer can only have 1. In an equation, the answer you get may not follow the rules of significant figures. You may have to round. Any number below or equal to 4, you don't have to round up a digit. So 17.3 would be 17. Any number above or equal to 5, you round up a digit. So 19.7 would be 20. When rounding, the amount of places you round to is determined by the number of significant figures allowed. When dealing with logarithms such as pH, only digits after the decimal are significant. So both 7.8234 and 19.6373 have 4 significant digits. When dealing with scientific notation, ignore times 10 to the something power. 7.5 times 10 to the 5th would have 2 significant figures, and 6.32 would have 3 significant figures. The times 10 to the 4th is not significant.